Good morning. Once again, welcome to our college physics class. And we are now on our week 2 for our discussion for today. Okay, so this week we are going to discuss physical quantities and units. So, what are these quantities and units involved in physics? So before we continue, let us have this. The distance, a photograph from showing the distance from Earth to the moon. Okay. So looking at the photograph, the distance from Earth to the moon may seem immense, right? So it may seem immense, but it is just a tiny fraction of the distances from Earth to other celestial bodies. So meaning, the range of these objects and phenomena studied in physics is immense. Okay? So from the incredibly short lifetime of a nucleus to the age of the Earth, from the tiny sizes of subnuclear particles to the vast distance to the edges of the known universe, from the force exerted by a jumping flea to the force between Earth and the Sun, there are enough factors of 10 to challenge the imagination of even the most experienced scientists. Giving numerical values of physical quantities and equations of physical principles, it allows us to understand nature much more deeply than those qualitative description alone. Okay? So to comprehend these vast ranges, we must also have accepted units in which to express them. And we shall find that even in the potential mundane discussion of meters, kilograms, and seconds, a profound simplicity of nature appears. All physical quantities can be expressed as combination of only four fundamental physical quantities, and those are the length, the mass, the time, and electric current. So in here, we define physical quantity either by specifying how it is measured or by stating how it is calculated from other measurements, or specifying how it is measured or how it is calculated from other measurements. Okay, so for example, uh, we define distance and time by specifying methods. Okay, so we have to specify methods for measuring the distance and time. Whereas we define the average speed by stating that it is calculated as distance traveled divided by time of travel. Okay, so that's one, the distance and time. Alright? So, here. So, physical quantities defined by either specifying how it is measured or how it is calculated from other measurements. So, our example there is the distance and the time. Okay? So, by determining the measurement to be used here, distance and time, we have to specify the methods in measuring them, all right? And for average speed, by stating that is calculated as distance traveled divided by the time of travel. Okay, so in here, the measurements of physical quantities are expressed in terms of units, okay, in terms of units there. So measurement of physical quantities are expressed in terms of units, okay, which is the standard or standardized values, right? So for example, we have the length of a race, which is a physical quantity wherein it can be expressed in unit of meters. Okay, unit of meters. For example, we have the sprinters, all right? So we are measuring the length of a race, units of meters, for example, sprinters, okay, or kilometers for distance runners. So without these standardized units, it would be extremely difficult for scientists to express and compare measured values in a meaningful way. All right? And there are two major systems of units used in the world. What are those? What are the two major systems of units? We have the first one, the SI units, or it is also known as the metric system. And the other one is, So for the SI unit, it is a standard system, okay? Standard system. And the SI is derived from the French system international, okay? The other one is the English units, okay? Also known as the customary or imperial system. Okay, so English units were historically used in nations once ruled by the British Empire and are also widely used in the United States. So virtually every other country in the world uses SI. Yeah, SI units now, okay, as the standard system there. Okay, wherein again it is also known as the metric system, wherein it is the standard system agreed upon by the scientists and mathematicians. Okay, wherein the abbreviation or the acronym SI is derived from the system or French system international. Okay, and we also have the SI units or fundamental and derived units. Okay, so uh, in here we use as non-SI units in a few applications where they are in very common use, such as the measurement of blood pressure in millimeters of mercury. Okay, whenever non-SI units are discussed, they will be tied to SI units through conversion. So we have here the following. I mentioned this one already a while ago. The length, mass, time, and then for electric current. Okay. So in here, some physical quantities are more fundamental than others, and that the most fundamental physical quantities can be defined only in terms of the procedure used to measure them. So the units in which they are measured are thus called the fundamental units. Okay? So we call them as the fundamental units. And another one, so we will be discussing in here that the fundamental physical quantities are taken to be the length, the mass, the time, and electric current. Okay, so by the way, electric current will not be introduced until much later in our lesson. Okay, so all other physical quantities such as force and electric charge can be expressed as algebraic combinations of length, mass, time, and current. Okay, example, we have the speed of length divided by the time. So these units are the derived units. So we call them as the derived units. Okay. Now we go to the units of time, length, and mass, the second, meter, and kilogram. So we have the second. Okay. The second, this is the SI unit for time. Okay, the SI unit for time, abbreviated S. Okay. So the SI unit for time has a long story. So for many years, it was defined as it was defined as 1 over 86,400 of a mean solar day, okay, for the year 1900. More recently, a new standard was adopted to gain greater accuracy, okay, and to define the second in terms of a non-varying or constant physical phenomenon, because the solar day is getting closer, okay, or getting longer due to very gradual slowing of the Earth's rotation. So therefore, cesium atoms are or can be made. So in here, okay, they can be made to vibrate in a very steady way, and these vibrations can be readily observed and counted. Okay, so in 1967, second was redefined in a redefined as the time required for here duration of so the second is the duration of 9,192,631,770 periods of the radiation corresponding to the transition between the two hyperfine levels of the ground state of the cesium atom. Okay, so that's the vibrations. So that is the required vibration. Okay. So accuracy in the fundamental units is essential. Why? Why essential? Because all measurements are ultimately expressed in terms of fundamental units and can be no more accurate than are the fundamental units themselves. Okay, so that is about the second. We have the meter. Meter is the SI unit for length, abbreviated by M. Okay, abbreviated by M. And meter, its definition has also changed over time to become more accurate and precise. So the meter was first defined in 1971 as 1 over 10 million of the distance from equator to North Pole. So this measurement was improved in 1889 by redefining the meter to be the distance between two engraved lines on a platinum iridium bar now kept in Paris. So this one. This is the platinum iridium bar. Okay? And by 1960, it had become possible to define the meter even more accurately in terms of the wavelength of light. So it was again redefined as 1,650,763 wavelengths of orange light, okay, emitted by krypton atoms. Okay, that is about the meter. Here, so the meter is defined to be the distance light travels in 1 over 299,792,458 of a second in a vacuum. Okay, so distance traveled is speed multiplied by time. Here, so we have here an example. Light travels a distance of 1 meter in these seconds. Okay. So the length of the meter will change if the speed of light is someday measured with greater accuracy. Okay, that's why accuracy is essential. So I mentioned earlier, accuracy in the fundamental units is essential. Alright, so because all measurements are ultimately expressed in terms of fundamental units. We have the kilogram, wherein this is the SI unit for mass, abbreviated by kg or uh, kilogram. Okay, SI unit for mass is the kilogram. Here, abbreviated by kg, and it was previously defined. It was previously defined as the mass of a platinum iridium cylinder, okay? Or the 3.9 centimeter in diameter and 3.9 centimeters in height. And it was all kept at the International Bureau of Weight and Measurement in France, wherein they established it in 1887. Okay, so exact replicas of the previously defined kilogram are also kept at the United States National Institutes of Standards and Technology, or the NIST, okay, located in Maryland, outside of Washington, D.C. Okay, and at other locations around the world, of course. So the determination of all other masses could be ultimately traced to a comparison with the standard mass, even though the platinum iridium cylinder was resistant to corrosion. Airborne contaminants were able to adhere to its surface. This one. So slightly changing its mass over time. And in May 2019, the scientific community adopted a more stable definition of the kilogram. And the kilogram is now defined in terms of the second, the meter, the Planck's constant, or H, okay, where it is a quantum mechanical value that relates a photon's energy to its frequency. Now we have the metric prefixes. So these SI units are parts of the metric system. Wherein the metric system is convenient for scientific and engineering calculations because the units are categorized by factors of 10. Okay? And metric systems have the advantage that conversions of units involve only powers of 10. There. Here. And there are 100 centimeters in a meter, 1,000 meters in a kilometer, and so on. All right? Here. So in non-metric systems, such as the system of US customary units, the relationships are not as simple. Like there are 12 inches in a foot, 5,280 feet in a mile, and so on. And another advantage of the metric system is that the same unit can be used over extremely large ranges of values simply by using an appropriate metric prefix. For example, we have distances in meters are suitable in construction, while distances in kilometers are appropriate for air travel. And the tiny measure of nanometers are convenient in optical design. So with the metric system, there is no need to invent new units for particular applications. Okay? Yeah. So the term of order of magnitude refers to, oh wait, wait. Here, before we go to the order of magnitude. So we have here the metric prefixes for powers of 10 and their symbols. So we have the exa, peta, tera, giga, mega, kilo, hecto, deca. Okay, so this one is the hexameter, petasecond, terawatt, gigahertz, megacurie, kilometer, hectoliter, decagram. And here are some examples. Some are approximate, okay? So prefixes for powers of 10 and their symbols. We have deciliter, centimeter, millimeter, micrometer, nanogram, picofarad, femtometer, and the attosecond. Okay, so here are some examples. For example, of deciliter, powers of 10. It is, for example, less than half a soda, centimeter fingertip thickness, like that. Okay? So the term order of magnitude refers to the scale of a value expressed in the metric system. Okay, so each power of 10 in the metric system represents different order of magnitude. So, halimbawa, meron tayo ngayon, power of 10. Okay, and so forth. So, these are all different orders of magnitude. Okay, and all quantities can be expressed as a product of a specific power of 10. Okay, here. They are said to be of the same order of magnitude. Okay, all quantities. Another one, we have example. For example, here, the number 800 and 450 are of the same order of magnitude, okay, because of this, okay, the power of 10. So they have the same order of magnitude. So the order of magnitude can be thought of as a ballpark estimate for the scale of a value. So the diameter of an atom is on the order of 10 to the negative 9 meters, while the diameter of the sun is on the order of 10 to the 9 power meters. Okay. So we have unit conversion and dimensional analysis. Okay, for in here, unit conversion, it is often necessary for us to convert from one type of unit to another. Okay, so let us consider this one, a simple example of how to convert units. Okay, so how are we going to convert units? Okay, so convert 80 meters to kilometers. Okay, so let's say we want to convert meters to kilometers and we have 80 meters. We are converting it to kilometers. So the first thing to do is to list the units that you have and the units that you want to convert to. Okay, so what is the given unit? So the given unit is we have, so follow the cursor. We have 80 meters. Okay, so here, first thing is to list the units that you have and the units that you want to convert. So we are converting meter to kilometers. Okay, so the given unit is 80 meters. So we say this is the given unit, and then the other one is the unit that we want to convert. So we call this as the desired unit, which is kilometers. Alright? Yeah. And then after that, in this case, we have units in meters and we want to convert to kilometers. So we need to determine a conversion factor relating meters to kilometers. So a conversion factor is a ratio expressing how many of one unit are equal to another unit. For example, we have there are 12 inches in 1 foot, 100 centimeters in 1 meter, 60 seconds in 1 minute, and so on. Okay? So in our case, we know that there are 1,000 meters in 1 kilometers, right? There are 1,000 meters in 1 kilometer. Alright? So we can set up our unit conversion now. So we will write the units that we have and then multiply them by the conversion factor so that the units cancel out. Okay? Like this. So we have to convert 80 meters to kilometers. And there are 1,000 meters in 1 kilometer. Okay? So multiply them by the conversion factor so that the units cancel out here. So we have to cancel now the meter and then multiply it. 80 times 1 is 80 divided by 1,000. Okay? So this is now equal to 0.080 kilometer. Okay? So that is a simple conversion. Okay. Let's have another example. Unit conversion. A short drive home. Example. Suppose that you drive the 10 kilometers from your university to home in 20 minutes. Okay? So suppose that you drive the 10 kilometers from your university to home in 20 minutes. Calculate your average speed. A in kilometers per hour, B in meters per second. Alright? So, Note in here that average speed is distance traveled divided by time of travel. Okay, here, wait. Oh, I will write here. Okay, average. So remember that. Okay, so note in here that average speed is equal to the distance travel divided by time of travel. Okay, so in our example here, we are going to calculate. Okay, calculate your average speed in kilometers per hour for letter A, and for letter B in meters per second. All right, so we have here, there are strategies for us to make. So first, we calculate the average speed using the given units, okay? And then we can get the average speed into the desired units by picking the correct conversion factor and multiplying by it. The correct conversion factor is the one that cancels the unwanted unit and leaves the desired unit in its place. All right, so we have here, let us solve for letter A. Calculate the average speed, okay? So average speed is distance traveled divided by time of travel, okay? So always take this definition as a given for now. So average speed and other motion concepts will cover in our next module, okay? So in equation form, we have, okay, just follow the cursor. So we have the average speed is equal to distance traveled divided by time, okay? Divided by the time of travel. Okay, so what's next? Substitute the given values for distance and time. So we are now going to substitute. So our distance is 10 kilometers and the time is 20 minutes. So this is now equal to 0.500 kilometers per hour. Okay? And then next, so we get now the average speed. So average speed now is this one equal to 0. So after we get this one, after getting this one, that's 0.500 kilometers per hour, calculate kilometer per minute to kilometers per hour. Alright, since we are calculating the average speed in kilometers per hour. Okay, so this is now equal to kilometer per minute, and then multiply by the conversion factor that will cancel minutes and leave hours. Alright? So we have to multiply. So there are 60 minutes in 1 hour. Alright? So we are converting our average speed into kilometers per hour. So we are now going to cancel the unwanted unit, which is the minute. So this is now equal to 30 kilometers per hour. So meaning you drove uh, your average speed by driving home to your from driving from your university to your home in 20 minutes is equivalent to 30 kilometers per hour. All right? So that's it. So that is for letter A. All right? So we already get the kilometers per hour, the average speed. How about letter B? So there are also several ways to convert the average speed in meters per second. So for letter B, we're calculating the average speed in meters per second. So first one is we have to convert kilometer per hour to meters per second. Okay, so in letter B, we need two conversion factors. Okay, one is to convert hours to seconds, and the another one is to convert kilometers to meters. Okay, so multiplying by the following here. Follow get the cursor. So we have our average speed, which is equal to 30 kilometers per hour, right? Then multiply by 1 hour to how many seconds are there in 1 hour? 3,600 seconds, okay? Times 1,000 meters in 1 kilometer. Okay? So what is next? So just repeat the step that we did in letter A for the solution in letter A by canceling the unwanted units. Okay? Because for our letter B, we are calculating the average speed or your average speed in meters per second. So in our conversion, we are now going to cancel the unwanted units. So we have kilometers, cancel, hour, and hour. Alright? So we now get meter over second. So our answer now is 8.3 meters per second. So you drove from your university to home 8.33 meters per second. Okay, that is in 30 kilometers per hour. Alright? So now we have the dimensional analysis using conversion factors to change units. Okay, this is to change unit. Alright, so we have example here. So before we solve our example, dimensional analysis uses conversion factors to change the unit in an amount into an equivalent quantity expressed with a different unit. Okay, so I repeat, dimensional analysis uses conversion factors to change the unit in an amount into an equivalent quantity expressed with a different unit. Okay, for example, a conversion factor could be used to convert this one, 3.55 meters to centimeters. All right. So perhaps we can determine the answer to this particular problem in your head already. However, the conversions that will be required for this will become increasingly complex. So it means, therefore, learning to appropriately develop and apply conversion factors is a valuable skill. So before we convert this one, there are 6 steps involved in dimensional analysis. So what are the 6 steps involved in dimensional analysis? Okay. So first, the given unit and the problem. Alright? So the given unit in the problem, which will be associated with a number. So as you can see, we have the given unit associated with a number determining here. Alright? It must be determined. In our example, the given number is 3.55 and its unit is the meter, okay, or meters. And then 2, the desired unit. So if we have the given unit, second steps, the desired unit, okay, which is the unit that the given quantity should be changed to or into. Okay, it must also be determined. And in our example, the given quantity should be changed into centimeters. So meaning our desired unit in our example is the centimeter. All right. Another one, the third step, determine which equality or equalities related the given and desired units. So in the simplest dimensional analysis problems, only a single equality is needed. However, more complex problems will require multiple equalities, alright? So, this step which can also be referred to as unit tracking, okay? Unit tracking. So, first one is we have to determine the given unit, all right? And we said that it is um, 3.55 meters. And we also have to determine the desired unit, which is the centimeters, right? So, in the third step, we can also be referred to as unit tracking. Okay, this is generally the most challenging step in the dimensional analysis process. So, meters and centimeters can be related by the prefix modifier equality 100 centimeters to meter or 1 meter. Okay? And then next is use the appropriate conversion factor derived from this equality to achieve unit cancellation. Okay? To achieve unit cancellation. So remember that the equality given here 100 centimeters equals to meter can be represented as two conversion factors. So, like this. So, this is a representation of our two conversion factors. 100 centimeters over meter and meter over 100 centimeters. Okay? However, only one of these conversion factors will allow for the cancellation of the given unit. Especially the unit to be cancelled must be written in the denominator of the conversion factor. Okay? So what's that? The unit that is to be cancelled must be written in the denominator. Okay, denominator of our conversion factor. So this will cause the given unit which appears in a numerator. Okay, to be divided by itself. Alright. So since the same unit appears in the denominator of the conversion factor, since any quantity that is divided by itself cancels, okay? So magka-cancel tayo ng unwanted unit. Orienting the conversion factor in this way results in the elimination of the undesirable or unwanted unit. So therefore, since the intent of this problem is to eliminate the unit meters, the conversion factor on the left must be used. Okay? Saan yung left? Yung left, ito daw. So, ito daw yung gagamitin natin na conversion factor. Kasi, we are, in our example, we have to convert this one into centimeters. Alright? So, why does this process work? Here, sulat muna natin. 3.55 meters times, so sabi ko sa yung nasa left yung gagamitin natin conversion factor, which is 100 centimeters over meter. Here. So, bakit daw nag-work yung process na yan? Why does this process work? So, in our example, 100 centimeters is equal to 1 meter. So, equivalent quantities appear in both numerator and denominator of the fraction, even though those quantities are expressed in different units. So, since the quantities in the numerator and denominator are equivalent, this conversion factor effectively divides the value by itself. Okay, divides the value by itself. And the entire process is equivalent to multiplying the given number by 1. Okay? Therefore, while the given quantity does not change, the unit does. Alright? And then perform the calculation that remains once the units have been cancelled. So, nag-cancel na tayo ng unit, yung undesirable unit, which is meters. Kasi kino-convert natin si meter into centimeters. So the given number should be multiplied by the value in each numerator and then divided by the value in each denominator. Okay, so kailangan ba natin gumamit ng calculator? Each conversion factor should be entered pag gumamit ka ng calcu. Alright, so there. So 300, this is 3.55 times 100 centimeters is now equal to 355 centimeters. Okay? So 3.55 meters is equivalent to 355 centimeters. Alright? So note that the unit that remains uncancelled becomes the unit on the calculated quantity. Okay, so this step 6 in dimensional analysis, apply the correct number of significant figures to the calculated quantity. Since the math involved in dimensional analysis is multiplication and division, the number of significant figures in each number being multiplied or divided must be counted, right? And the answer must be limited to the lesser count of significant figures, okay? So, there. Therefore, since the conversion used is based on the prefix modifier equality, 100 centimeters equals to meters, the 100 is not considered when determining the number of significant figures, okay, that the answer should have. However, the given number 3.55 is not exact, and its significant figures must be considered, okay? So, dapat consider kasi hindi naman exact, okay? Yung given number. So, as this value has 3 significant figures, the final answer must have 3 significant figures. Kagaya yan, 3.55. So, kailangan yung final answer natin, it must have also a 3 significant figures. Alright? So, since the number of digits that the answer actually has is exactly equal to the number of digits that it should have, no adjustments need to be made. Okay? No adjustments need to be made. And the calculated answer is the final answer. So that is dimensional analysis. Let's have another example. Using a conversion factor based on an equality, perform the following conversions. We have letter A. Letter A. 5.8 minutes to seconds. 5.8 minutes to seconds. And letter B, 7,320 feet to miles. Okay. Oh, wait. Here. So, for letter A, we are converting minutes to seconds. Alright? So, what is the given unit? The given units for letter A is, let's write letter A here. The given unit is the minutes, all right, and the desired units is the seconds, all right. So these units can be related by the measured equality. Ano yung measured equality ng given units and desired units natin? Talking about minutes and seconds. We have 1 minute equivalent to how many seconds? 60. Okay? So the measured equality for letter A is 1 minute equivalent to 60 seconds. So the quantity on the left, the quantity on the left-hand side of the equality must appear in the denominator of our conversion factor. So kailangan yung minute, mag-a-appear siya doon sa denominator. Okay? Doon sa denominator ng conversion factor later on. So in order for us to achieve the unit cancellation. Okay? So how is that? So we have 5.8 times, wait. So 5.8 minutes, minutes times. So I mentioned earlier, in our measured equality, 1 minute or this minute on the left side of our equality should or must appear in the denominator, okay? For us to achieve the cancellation or unit cancellation. So, lagyan na natin siya, 60 seconds over 1 minute, okay? And then, proceed now to the unit cancellation. So, 5.8 times 60, okay? Times 60 divided by 1. So, this is now equivalent to 348 seconds. Okay, so in 5.8 minutes, it is equivalent to 348 seconds. All right. So both the 60 and the 1 are exact number as they are found within a measured equality. Okay, they are found in a measured equality. So the given number 5.8 is not exact and its significant figures must be considered. So as this value has two significant figures here, the final answer must have two significant figures. Since the number of digits that the answer actually has is more than the number of digits that it should have, the calculated answer must be rounded. Okay, must be rounded to 350 seconds. Okay. How about letter B? For our letter B, 7,320 feet to miles. Okay, so what is the given unit? The given unit is feet and the desired unit is miles. Okay, so these units can be related by the measured equality, which is, what's the measured equality for feet to miles? Burahin na natin yun. Okay. So the measured equality for feet to miles is equivalent to 1 mile equals 5,280 feet. Okay? So the quantity on the right-hand side of our equality must appear in the denominator of the conversion factor. Okay? Dapat mag-appear daw yung ito. Si 5,000 to, the feet. Yung feet na unit. Okay? Para doon sa unit cancellation. Okay? So, sulat na natin. 7,320 feet times okay. So 1 mile over 5,280 feet. Okay. So this one, we now go to the unit cancellation. So cancel natin yung feet and feet para maiwan si mile kasi kino-convert natin yung feet to miles. So this is now equivalent to 1.3863633 lang, and so on, miles. Okay? So both 1 and 5,280 are exact numbers as they are found within the measured equality, right? So the given number 7,320 is not exact, and its significant figures must also be considered. As this value has 3 significant figures, the final answer must have 3 significant figures. Since the number of digits that the answer actually has is more than the number of digits that it should have, the calculated answer must be rounded to 1.39 miles. Okay. So that is the dimensional analysis, okay? Using conversion factors to change units. Now we have the multiple conversions. What about the multiple conversions? So, as mentioned in the previous section or in the dimensional analysis using conversion factors to change units, the conversions that will be required for multiple conversions will become increasingly complex. So due to either the type of unit being cancelled or the number of conversion factors that must be used to achieve the desired unit transformation. So in here, we have to explore more, alright? So are you ready? We have another example. Okay, so in multiple conversions, so we have to, for example, convert 0.547 kiloliters to deciliters. So using only conversion factors based on the equalities, okay? So following the sixth step, dimensional analysis process found in our discussion a while ago must still be applied, right? So step 3 in particular. So we will need to be considered more thoughtfully in order to arrive at the correct answer. So again, determine the given unit. Okay, so the given unit is, what is our given unit? Here. Given unit 0.547 kiloliters. Okay, and then another one is the desired unit in the problem, which is the deciliters. So deciliters. So the given quantity should be changed to deciliters. So making it as the desired unit. And for step 3, determine which qualities relate the given and desired unit. So, ano ba yung equalities na nagre-relate sa kiloliters and deciliters? So, in this case, equalities will be necessary to achieve the required unit change. Okay? So, it does not reference an equality that directly relates kiloliters to deciliters. However, each of these units can be related back to a common base unit, which is the liters. Okay? Babalik tayo doon sa liters. So, kiloliters and liters can be related by the prefix. This one, kiloliters is related to 1,000 liters. Okay? So, the right side, saan yung right side dyan? The right side of this equality is simplified, is the simplified form of 10 to the 3rd power, which is the meaning of kilo. Okay? So, liters and deciliters can be related by the prefix modifier equality. Liter or L is equivalent to 10 deciliters. Okay? So this equality is twice simplified form of 10 to the negative 1 liters to deciliters. Okay? So derived from the meaning of deci. And then, what's next? Use the appropriate conversion factors derived from these equalities. Okay? To achieve, ano yung para ma-achieve natin yung unit cancellation. Okay? So, apply na natin yung given unit, which is 0.547 kiloliters times 1,000 liter is equivalent to 1 kiloliter. Tama? Times 10 deciliter is equivalent to 1 liter. So we are now going to have our unit cancellation. Okay, so naiwan na si deciliter. And then calculate. All right. So noted in each step, the previous unit is cancelled. Okay. The next unit in the sequence is produce. So ayan. So na-produce na natin yung. So natanggal na natin si kiloliter. Hanapin natin yung equivalent equalities ni liters. So nakuha natin yung 10 deciliters is to 1 liter. Okay, and then proceed again to cancellation until the desired unit remains. So, ano yung natirang unit? Yung desired unit natin. Yung deciliters. Okay, kasi na-cancel na natin yung mga unwanted units. Okay, and then perform the calculation that remains once the units have been cancelled. So, in our case, this is now equivalent to, sulat natin para mas klaro, times 1,000 times 10 deciliters. And this is equivalent to 5,470 deciliters. Okay. So, apply the correct number of significant figures to the calculated quantity. Okay? So, dapat na-apply natin yun. Since both conversions use are based, so yung nagamit nating conversion are based on the prefix modifier equalities. Ito. So, dito tayo nag-base sa prefix modifier equalities. So neither the 1,000 near the 10 are considered when determining the number of significant figures that the answer should have. Okay, neither nor. The given number has 3 significant figures, so the final answer must have 3 significant figures. Since the number of digits that the answer actually has is exactly equal to the number of digits that it should have, no adjustment need to be made, and the calculated answer is the final answer. Okay, did you get it? Let's have another example. convert 1.3 weeks to hours. Okay, so we are going to convert weeks to hours. Okay, so determine the given unit. The given unit is weeks and the desired unit is hours. So these units can be related by the measured equalities. What are the measured equalities? So in 1 week, there are 7 days. Okay, there are 7 days. And 1 week is equivalent to 7 days, and for 1 day is equivalent to how many hours? 24 hours. Okay. Therefore, we have 1.3 weeks is equivalent, I know. 1.3 week is multiplied to, so in 1 week, there are 7 days. Okay, so we cancel the undesired unit. So natira si day. So para makuha natin si hour, so in 1 day, there are 24 hours. So cancel again the undesired unit. Okay, and then proceed to calculation. 1.3 times 7 times 24. Okay, 1.3 times 7 times 24, and then we have the unit. Okay, and this is equivalent to 218.4 hours. Okay, so 1.3 weeks is equivalent to 218.4 hours. So each of the numbers found within the measured equality is exact. Okay, so ito, yung measured equality natin, exact sila. The given number has two significant figures, so the final answer must have two significant figures. Since the number of the digits that the answer actually has is more than the number of digits that it should have, the calculated answer must be rounded to 220 hours. Okay? Dahil hindi exact yung given unit natin. So, yung calculated na sagot should be rounded. Okay. So, let's have another example. Okay. Use only conversion factors based on the equalities. 1 point, no, converting 952.1 centimeters to yards. Okay, so what is the given unit? The given unit is centimeters and the desired unit is yards. So these yards can be related to the measured equality 1 inch, 1 yan. So in 1 inch, there is 2.54 centimeters. 1 feet is equivalent to 12 inches, and 1 yard is equivalent to 3 feet. Okay, so therefore, 952.1 centimeters times, so dapat yung centimeter na mag-cancel dun sa unit natin, yung given unit, nasa denominator. Okay, so we have 2.54 centimeters is equivalent to 1 inch. Cancel na natin yung centimeter. And then next, inch to yard. Okay? Pero bago yan, ito muna. Yung feet natin. So, cancel muna natin si inch. So, 12 inches is equivalent to 1 feet. Okay, so cancel, cancel. And next, yung desired unit na natin na reach na 1 yard. Okay, cancel feet and feet. So, naiwan na si yard. Okay, so this is now equivalent to 10.4122 and so on yard. Okay, so again, each of the numbers found within a measured quantity is exact. The given number has 4 significant figures here. So it has 4 significant figures. So the final answer must have as 4 significant figures. Since the number of digits that the answer actually has is more than the number of digits that it should have, the calculated answer must be rounded to 10.41 yards. Okay? So that is multiple conversion. Okay? Multiple conversion. So next, what to do? What are you going to do? So following the steps that we just have learned in unit conversion, so what are you going to do for your activity? This is already provided in your module, I should say, by solving the following. So solve the following and then show your complete solution. And of course, once again, encircle your final answer. Okay? So ito, yung number 1 natin. The speed limit on some interstate highways is roughly 100 kilometers per hour. So solve for the following. A, what is this in meters per second? Okay. P, how many miles per hour is this? So you have to calculate for the first one is the meter per second, and then another one is another desired unit is miles per hour. For number 2, a car is traveling at a speed of 33 meters per second. So you have to calculate for the desired unit, kilometers per hour for letter A, and for letter B. Answer the question, is it exceeding the 90 kilometers per hour speed limit? Okay, show your solution and then answer this question, yes or no. And then, for number 3, American football is played on a 100-yard long field, excluding the end zones. So, how long is the field in meters? Assume that 1 meter equals to 3.281 feet. Okay, how long? And number 4, soccer fields vary in size. A large soccer field is 115 meters long and 85 meters wide. What are its dimensions in feet and inches? Assume that what's that? The measured equalities is 1 meter to 1 meter is equivalent to 3.28 feet. Okay? So, yan. So you have to find the desired unit, feet and inches. And for number 5, what is the height in meters of a person who is 6 feet and 1 inch tall? Okay, so given the measured equalities, 1 meter is equal to 39.37 inches. Okay, so simple as that. Just solve the following by showing your complete solution and encircle your final answer. Okay, please do this in a yellow pad paper. Okay, to be passed anytime again this week. So that is all about physical quantities and units. So I hope you understand our discussion and do some research about unit conversion, okay, for your home or for your requirements. Okay, so thank you and God bless.